Okay, so today's topic, introduction to game programming. We're going to talk about an array of baskets. All right, you probably remember now in our previous videos, we've got basically almost a game going on here, right? We can move the basket left and right according to the mouse motion. We are catching apples, and if we miss, all apples get destroyed. And so we're in pretty good shape, except we're not managing our baskets at all. So let's talk about managing the baskets. Now, you'll see last time we did set up how to move the baskets, and we did that by making the chest here, the chest basket, whatever you want to call it, we made it a child of the player, right? Now, since we want to have multiples, what is that immediately? A thing should go off in your head and say, okay, multiples. Okay, chances are I want to use prefabs for that. Okay, especially when it's got colliders on it, rigid body, chest, whatever. We want those on there. All right. So we're going to go ahead and we had apple tree prefabs. Right now, I have a basket array set up, but let's start from a fresh one here. Okay, we're going to put our Lego chest in here. Our old baskets is going to look pretty similar. That was from another version of this game, but let's use this new one, Lego chest here. Now, we did have this chest behavior script, right? And if we go to our game here, we have the apple tree player, which is moving the player, which in turn for free kind of moves the chest, right? The chest really doesn't have anything on it yet, doesn't do anything during update. All it does is say, okay, if something collides with me, I destroy it. Well, I don't even do that. I just play a sound, right? The apple itself knows if it collided with the chest, then it got destroyed. So really the chest doesn't do much of anything here, does it? Right? All it's doing is making that sound. So let's see. We have that script on there. Fine, all good. And let's go back to our scene. So let's say in this scene, if we wanted to now instantiate the chest, right? Because we want to have multiple chests that we want to keep track of. Let's see. I guess in theory, you could, if you didn't want to, we could just put 3 chests there if we wanted to design that way. But let's not do it that way. We could, but we won't. So what we're going to do is in the player, right? The player is what controls the chests. So let's go to the apple tree player. And what we're going to do in the start of the apple tree player, we are going to instantiate that Lego chest there. All right, so as usual, we're going to need a reference to a game object as a prefab. And we're going to call this chest prefab. And one other thing we're going to need to do is we're going to make sure that this is public, or we could make it serializable. Serializable means private but accessible to the Unity interface. Right, so we say serialized field. If we said that, we didn't make it public. This is kind of one fun thing here. Fun fact, right? Other classes don't get to talk about it, but we will see that, yes, over here in the Unity editor, we can talk about that chest prefab. So let's go ahead and do that. We're going to go to the apple tree prefabs. We're going to take our Lego chest and we're going to drag it and put it up in there. All right. So now our apple tree player script knows about the Lego chest. And because it does, we're going to go ahead and delete the original. Right. So now it's going to be to the job of the player to go ahead and instantiate some chests. So in start here, I could very well say, all right, instantiate, and it's going to be, where are we? Chest prefab. Whoops, not that. Where's that going? Chest prefab. There we go. Now, we want it to be, what do we want it to be? We want it to be new vector 3. And in this case, it's kind of interesting in that we want it to be at 0. Right? It has no location of its own. It's just offset from the player. So it starts at 0, 0. And we're also going to put it at, we're going to have no rotation to it. Quaternion dot identity. Okay. So if I do that, you'd think, okay, I'm going to instantiate a chest. And I will. All right, click over here and see what happens. Make sure, yeah. All right, play the game. And you see there's a chest. And the problem is that the chest is not moving. Right? So I'm going to pause for a second. Why is that happening? The chest is there, it's in the scene, but it's not moving. If I look over here, I'll see, Lego chest clone, that happened. But what didn't happen is that the player and the chest don't have any relationship. You'll see that the player, or the Lego chest clone, is not a child of the player. All right, so we're faced with this challenge. How do we instantiate an object as a child of another object? Okay. So in order to do that, we have to do things slightly different. If I say this, I believe this is the version, instantiate chest prefab, and I just say transform, which is the transform component of this object, it implies something important. It implies that this object is going to be Apple Tree Player Prefab is never assigned to. Oh, that's fine. It implies that the thing that you're instantiating is going to be created as a child of this object. Transform, in this case, transform is kind of special. Transform isn't just the transform. It really refers to, in some ways, the game object, right? Kind of interesting, right? It's kind of smart in that way. So say now we instantiate that, and we could very well instantiate 3 of them if we wanted to, right? So in this case now we want to have an offset though. So what other versions of instantiate do we have here? So if we come over here, we can see 9 overloads here. So normally, if we look for that, you can see all of the overloads. All right. So what do we have here? We have instantiate. You can instantiate the current, instantiate original position quaternion transform parent. Okay. Right, so this is the version we used here, original transform parent, where T is object. So the version that we want to use is the original with a position and a rotation and the parent. Okay, so that's fun to do from metadata. All right, so we need an offset and a rotation in there. So if we started this one off, the normal one here at just 0. So here, the next one would be at what? It would we would say new vector 2 or vector 3, and by default it would be 0, 0, 0. Let's just put this as a placeholder, comma, and then we have to have a rotation. Boy, my typing is not, I've got the wrong glasses on today. Quaternion.identity, comma, transform. Okay, so this is a valid thing to do. We'll do it 3 times. And what we want to have happen in between each one, of course, is we want to have some sort of offset. And who knows, maybe we even want the first one to be offset a little bit. It's kind of at the bottom of the screen. All right, we'll leave it there. So what's happening? We want this y to change. So say we said -1, -2. So the first one is, well, let's see. Let's go ahead and do this. Just see if you can spot it. I'm sure many of you will spot what we want to go for here. 0. All right. So 0, 1, 2. Negative 1, 2. Save. Here. Back to the game. Look at that. 3 apples. They're awfully big. Or 3 chests. They're awfully big. Not at all practical, of course. So what we should really probably do at this point is say, I'm going to go over here to the prefabs, apple tree prefabs, Lego chest, probably do a little bit of scaling, right? So what did I do in the other one? Let's see. Did that have a scale? No, it didn't. I must have changed the camera size or something like that. Lots of different ways to approach this, but for now, let's do it this way. We'll say, okay, 0.2 and 0.2, and for the sake of argument, 0.2. All right. Play the game. Maybe 0.2 isn't the right thing. Well, who knows? Maybe we want to scale. Look at that. That was kind of interesting. What happened here? Interesting. See how see they're kind of moving? Why is that, you may ask? How did they get offset? Well, those actually do have rigid bodies on them. And they have, because they have rigid bodies on them, they are going to be subject to physics. So they are getting kind of shifted around a little bit. So I may actually want to, for the sake of argument, remove the rigid body. Whoops. No, I didn't want to do that. So let's go to the rigid body here. And we will remove the component, the rigid body component, from the chest. And we'll play the game again. Everything still works, but we don't have that weird kind of side effect. Okay, and you'll notice I can catch them with any basket. So I'm allowed to kind of come in from the side, which is okay. I like that. All right, so all 3 baskets are sort of active. Now I'm going to probably want to get fancier here and say, okay, -1, -2, that's too large a value. -0.5, -1. What happened here? All right. Save. Play the game again. They're kind of a tighter group here. And also, let's see. Let's go to their scene. And where's our player here? Our player is there. And our chest, our first chest seems to be at a really crazy spot there. Why is that? So the chest is at 0, 0. So somewhere, something has crept in that the offset is not quite, looks like it's not quite relative. Let's see here. We'll go to the game. And we hit pause. I want to see the game here. There's the 3 apples. There's, I want to look at the hierarchy in the scene here. And you'll see 4.25, 3.75, and 3.25. So the question is, where did this 3.25 come from? Right? Why did that? Where did that happen? That's a good question. Sometimes it's an obvious one, sometimes it's not so obvious. So in my instantiation here, I instantiated the parent. Oops. this is the position, which is somehow we're using a local position rather than a parent offset position, right? So here we go. This is world position stays, right? And here we have the transform position, original, transform, instantiate in world space. Vector 3, why don't I remember? I don't see, I'm thinking, why haven't I had this problem before? So let's go, for the heck of it, I'm going to look at an older script here just to try to remember where I'm coming from. So in this other, I think, player controller, let's go to player controller. Start public, nope, not that one. Let's go to tree script, right? All right, allow that. So, pardon me a second here, tree script, throw Apple, slightly different version. Oh, no, we want this to be, is it game manager? Yeah, looks like game manager. Pause play. This is the problem when you do it too many different ways, and each time you refine what you're doing here, sort of. Player controller, player script. Let's look over in here just so I'm not opening things every time. Player script. Oh, there we go. That's where that happened. All right. So go to player script. And you see we've created basket lists here, and we used transform.position. Okay, well, all right. We use the actual position minus the offset, or plus the offset. We didn't just, right. So to do that right, let's try that. So I'm just, tree script, just behavior, Apple behavior, where were we? Game manager, now I've lost track. Apple tree player, there we go. So here we're going to say, transform.position plus. All right, so we need to say the transform position plus that offset. See if that works properly. All right, save that. Too quick with my. All right, now we're down. Yeah. So we're at the bottom of the screen, and we're offsets from the bottom of the screen. So that's good. So the bottom one is at, right, if we look at the player, right, because the player is effectively at the bottom of the scene there, right? And everybody else comes up from there, right? If I press play and pause, let's look at these chests. One of them starts at 0, the next one at -0.5, and the next one at -1. All right, so there, I'm going to refresh my memory on that one. So maybe they need to be offset by more than this. Maybe they should be moved up. And I can tune them. I can say, okay, that first one, -1. The next one should be at -1.5, and the last one should be at -2. Right? It's subtracting from there. So is that good? Is that right? What's going on? Plus a negative number, so that's going to be moving it. Oh, okay. No, wait a minute. This is going to be weird because I'm adding it. If I'm going from the bottom to the top, right, I want to just add a number now. Right? Remember, I'm at the edge of the screen, working my way back towards the top of the screen. That means I'm adding a value. So this is the bottommost one, then the upper, then the upper. Let's do that. Right? display. There we go. That makes sense. Pause. There we have one at 1, we have one at 1.5, and we have one at 2. All right, so everything's good now. Right? Everything's good. And you'll see that they're all according to this negative 4.25. It's kind of a little bit weird in that this is a local, kind of a local position or a local offset. We'll go with that. All right, whoops, you know what, my control panel. Let's see this. All right, so we're at this point, we're able to create this. Now, what I want you to do as an exercise, I'm not going to demonstrate this part, but what I want you to do is to do this as a for loop. Right? We see this is slightly changing, so with your for loop, you can change the value in there each time. And potentially want to keep these because you want to do something where you want to say, okay, if a chest is destroyed, you want to ultimately, from top to bottom, destroy them, right? So how do we do that? We need to have something in here. I'm going to say, okay, void, well, we'll call it this. We'll say lose life. This is the lose life function, right? And the job of this is going to be to delete one of these things here, right? And you could even, if you want to get fancy, if you want to challenge yourselves, void gain life. Right? So if you wanted to have something where with a high score, if you exceed the high score, you gain a certain number of points, whatever, you can add a life back. So maybe you use this gain life. You start off with 0 lives, and here, right in here, you'd say gain, 0, 1, 2, and so on. So we'd want to put them in an array. I know you could do it either way. You could say, you could do all sorts of different things. But for now, we want to say basket array. All right. So we have a basket array. And declare managed array, rank precedes. So let's create one with 5. Bad array declarator. What did I do wrong here? It's too early in the morning. Too early in the morning. Nope, not tree script. Is it player script? Yes. Here's what I did last time. I created a list of baskets. That's not what I want to do this time. This time I want to do basket array. I'm sure I have in another version here my basket array, and I'm just too early in the morning. One second here, let me think. Oh. Oh, I'm just backwards. I'm all kinds of backwards this morning. You have to bear with me here. All right, basket array. That's how we're going to declare that. And we're going to say right here in start. Not enough coffee yet. Equals new game object 5. All right, so at most we're going to have 5 baskets. Right, we're reserving this array. We're going to say, okay, up to 5 baskets. All right, so we could assign them to keep track of them. Wow. There we go. No, that. We had caps lock on. Do we still have caps lock on? Okay. Okay. So now I'm going to store all these in this array so that if I need to destroy a basket in here, I could figure out, okay, which one's at the top? Well, actually, this one's at the top. 2 is at the top. So maybe I should have done this. And then I could say, all right, remove basket 0, remove basket 1, remove basket 3. Okay. If they're in a certain order, I know I can lose lives in certain order. I can say, okay, number of lives is the one to destroy. Right? I hate to do this all exactly, but this is the challenge, doing it programmatically. Right? Which one of these do you want to destroy? If you gain a basket, should it be last in, first out, first in, last out, and so on? Right? What happens when you lose one? Say, just for now, we'll say, all right, here will be my last hint, int, and we'll say lives left equals, you start off with how many? 3. 0, 1, 2, and we could say, if we know that 2 is the, topmost one, we would say destroy basket array lives left -1, and then we would say lives, we can even do this. We're going to use a I know I'm being fancy here, minus lives left. That means pre-decrement lives left, and use that as the index, right? So if 3 lives left, you would say, okay, 3 minus 1, that's 2. Refer to basket array 2, get rid of that one, and so on, right? So lose life, and what I'm going to do here, I'm going to say lose life is a static. Can I do that? Nope, because an object is required. Object reference is required for the non-static field method or property. All right. So this basket array is not set up here. So let's see. Can I get away with this? Let's see if it'll let me do this. And we say that there is only one. I might have been able to get it with that even in there. I just needed to do this part. Right? I probably did that. I get overly cautious. Right? That could be there. I think that could be there. I'm going to redo that. This is what you get for doing this early in the morning. Is it happy now? Lives left is not static. There. All right, so now this complies with everything I need for it to be static. Why did I do that? Why did I create it static? Well, there is only one basket array. There is only one thing here. You can only ever have one. So arguably, this should be a singleton. The Apple Tree player should be a singleton. And almost everything in here potentially could be well, no, not all of them could be static because you have to be, declaring these as part of the actual game that's coming up. So, but now the cool thing is I can refer to that, and I'm going to do this. I'm going to say, okay, where is our Apple behavior? And what's going to happen is if we destroy all apples, what the implication is that we are also destroying a basket, right? So I could say in here, that was in Apple Tree player dot wasn't that where it was? Did I do that? Lose life. Say it, yep. Okay, chess behavior, nope. Apple behavior. Why can't I do that? Class Apple Tree player. Static void lose life. Oh. Why couldn't I do it? Well, because it wasn't public. Now you'll see it shows up. There we go. That's better. All right. So if I miss an apple, I destroy all the apples, all the other remaining apples, and I tell the apple tree player to lose a life. Quick and dirty. Now I need to be careful here. I'm going to leave this up to you. What's going to happen? I'm going to leave it, it'll crash. Ready? If I do this, that's okay. But now I have no, okay, didn't crash, but it complained. Index out of range. Why is that? Well, I am basically doing this destruction in Apple Tree Player, destroying a basket, but I'm not checking to see, do I have lives left? Now, if you refer back to our array lecture, you'll figure out, okay, how do I figure out the number of things in the array? Or maybe this, you can just say, oh, okay, if I've got more than 0 of them, I can get rid of one, right? And the other thing is I want to add a life, gain a life. Now, this looks like a good place, you know. So what does gain life look like? Gain life looks like this. Is that 0? It started at 1. Does that work? Not quite. Because I should start out with 0 lives. I think that's the leftover one. Clear that. All right, so now if I wanted 5 lives, what would happen? How would I get 5 lives for starters? Where are we? Apple Tree Player. Okay, I'm going to leave that to you to be creative with cleaning up this code. Can't write all the code for you. I probably wrote already too much. So manage the arrays as manage the baskets or the lives or whatever it is as an array. I want you to do this. Why specifically? Well, I want you to be working with child objects, manipulate them, see the way that we're using the transform to move things around like that, and also managing an array, managing the bounds of the array, making sure, so you might want to say, only add enough baskets that will fill the array. So you want to check that length. You want to be looking at the array, the length or count. Figure out which one. Go back. All right. So this should really, you've got all the mechanisms now. You're going to want to have a score counter. You're going to have a high score. We'll talk a little bit about high scoring in a bit. But all the mechanisms are there now for the base functionality of the Apple Tree game, right? In a far more, I think, a more potentially more elegant way than the textbook. So challenge yourself with this one. Again, like I said in the last video, try to go and make it as lean as possible, right? Use these kind of techniques so that the core functionality here, like look at this is pretty slim. And if I were to change this to maybe a for loop, certainly there needs to be some bounds checking and things in here, but there's not a lot of code required in here. So challenge yourself to make a nice, clean core to this game. Don't put two versions of it in the same directory. You also wind up with or three versions in the same directory. But yeah, it doesn't. You want to go through. Obviously, this needs some more commenting. The behaviors. Not a lot going on here. So we could even strip out functions here that are unnecessary, right? So that's the challenge in this one. Start off, make it nice and clean. You're going to want scoring. You're going to have high score that we're going to manage. And then there's lots of room in this potentially to get fancier, right? There are going to be things like maybe there are multiple different things that could be dropped, and each of those may have different point values, or maybe they have different behaviors. Right? If you drop poison, you drop a bomb or a rotten apple, don't catch that, right? If you catch that, then what happens? I don't know. Your score goes down, or you lose an apple for catching it instead of dropping it, and so you're going to manage that difference and so on. Maybe you're going to have things where use the offset, create different structures and organizations of the baskets, things like that. You can certainly get fancier in here. If you look at all the different genres of this is a typical arcade style game, from Galaxian, Galaga, etc., etc., etc. You could do some reasonable stuff with this core mechanic of stuff coming from the top of the screen and you deciding, do you need to catch it or do you need to let it pass? And if you really want to get fancy, what could potentially happen is if you catch a certain type of item, does that give you the ability to shoot a projectile up? And does that hit the tree? What happens then? I'll leave that up to you. Okay. Have a great weekend.